So our question is, a molecule of Cl2 shares 2 atoms of chlorine. Show this reaction in an electron dot diagram. So a good way to start on this is to just draw out 1 atom of chlorine. So we'll do that by getting the valence electrons of chlorine, and that happens to be 7. And once we've got that number, we can then write out our chlorine and then draw in the 7 dots around it, keeping in mind that you can't have more than 2 on each side. So 1, 2, 3, 4, 5, 6, and 7, leaving 1 on this side, 1 free on this side, that is. And this question asks for 2 atoms of chlorine. So a good way of figuring this out is by making this a sort of equation. So we can do that plus another chlorine. I'll copy paste it. That plus that will equal something, and what that is, this is one compound. It's not 2 of them. They're both being combined in some way, and so we need to find a way to merge these 2 together, and we do that through sharing electrons. If we notice on each side, this is a full side and this is also a full side, and that's the case here, here, and here, but not on this one. This side only has 1 electron, and because these are the same atom, this side also only has 1 electron. So what we can do is we can make them share electrons, and the way that you would draw this is by not doing that. Let's get rid of that. Is by drawing out our 2 chlorine atoms, and now we need to rotate one of these or both of these, depending on the question, to make sure that these 2 are facing each other so that they each share an electron. So if I recolor these into different colors so that you can differentiate them, I'll make this one red, and I'll make this one white, I guess. And so when they share electrons, the white one will go down here and the red one will be up here, and then all their other electrons will remain the same in this case, but they will these 2 will be shared among the 2 atoms, therefore creating Cl2. The proper way to write this, you don't always have to write it out with all the dots. The proper way to write this is when you've got just 2 electrons in this bond here, 1 electron each being shared. That's a one link, I guess. So when you write it out, you could write it out, and this would be more technically correct, to write it out simply as Cl and then a line and then Cl, capital C's, and that's the most appropriate way of doing it. There is more than 1 type of bond, of course, because this is sharing 1 link between 2 atoms. We can call that, I guess, a single bond. But there's other types of bonds, and I'll talk about the double bond now. So our question is, show the bond between 2 oxygen atoms. So the first bit is to get our proper formula for 2 oxygen atoms, and that will be just O2. because, you know, 2 oxygen atoms. And then the second step would be to write out our diagram of these 2 oxygen atoms. So I'll pick a different color and start writing. So we've got oxygen. Oh yes, and we need to know how many valence electrons oxygen has. Oxygen has 6 valence electrons. So when we write out oxygen, we do 1, 2, 3, 4, 5 on one side, 6 on another side. And then we do the same thing where we do plus and an oxygen, and then we do 1, 2, 3, 4, 5, 6 on individual sides. And now we can do what we did before, where we write them as sort of like we did before, but this time it's double bond, and I'll show how that works. That's why I wrote them in different colors. So it's the same thing where we write out O and O, and actually I'll put that a bit closer. And our first oxygen, it's easier to differentiate if you put these ones on an angle. So counting them 1, 2, 3, 4, and then because we've still got 2 more electrons, but we need to fill up all sides on our original diagram here, we just put them both in the middle here, so 5 and 6, and the same goes with our other oxygen. We can do 1, 2, 3, 4, and it doesn't matter where these are really. You could do them like that, I believe, and that would still technically be correct, but just for reading, it's easier to read like that. And it also suggests the actual structure of the compound, which I might talk about later. And so that's 4, and then 5, and then 6. And so as you can see, they are now all stable. Each side is filled, and each atom is sharing their electrons to create a full shell for each other. And as I did before, there's an easier way of writing this, and that would be oxygen, and before we had 1 line between them, so because we have 2 bonds now, we can have 2 lines between them, and then just write our other oxygen. And that's double bonds. So our question for this is carbon dioxide is written as CO2, and that is CO and a smaller 2 there. And then we are asked to write a diagram that represents this bond. So we've got a carbon and 2 oxygens. So we can start by writing out our valence electrons for carbon and our diagram for carbon, and we'll do that in green. So our valence electrons for carbon is 4, and oxygen is, I'll do oxygen in blue, equals, oxygen's got 6, I'm pretty sure. Yeah, 6. And once we've got them, we can draw out our equation. So oxygen, oxygen 1, 2, 3, 4, 5 on one side, 6 on the last, and plus the same thing, or actually a better way of doing it is doing our carbon next, just to get that out of the way. So our carbon would be plus carbon, and because there's only 4, we'll do 1, 2, 3, and 4, because we have to have 1 on each side, and then add on our last oxygen, and I'll copy paste that. Oops. Okay. And then as before, that will equal something. What that equals is the sort of the same deal where we rotate our atoms so that they can share the right amount of electrons. Because carbon doesn't contain any full sides, it means that every single side here is a bonding side. So to write this, we'll start with our oxygen, and we'll write 1, 2, 3, 4, and then 5, 6 here, sort of like what we did in the last one. And then we'll write out our carbon, and remember carbon only had 1, so we can just put our 1 carbon in there. There's 2 oxygen ones, we need to balance it out, so we can put in our other carbon one there, even though writing out carbon by itself would be there, and then that one would be there. For the sake of the diagram, when you're making the molecular compound altogether, it's just easier to put it like that. And then it's the same thing on the other side, where we draw out 2 greens for our 2 carbon electrons, and then our oxygen and oxygens 2, and then the other 4 to make 6 electrons for our oxygen. And so that will be our complete one, and just like before, we can write this as a double bond, but it will be slightly different this time. We will write it as oxygen, and there's a double bond here, so equals, or the 2 lines to indicate that there's 2 bonds, carbon, and then because there's another oxygen attached on it, we will do another oxygen, and that's a molecular compound dot diagram.